Hello students, today we are going to see normal probability distributions. This normal probability distribution comes under continuous probability distribution. Okay, in the previous classes and all we had seen the discrete probability distribution. So today I am going to explain normal probability distribution under continuous probability distribution. So the outline of this chapter I'm going to give you the introduction to normal distribution. And then second section tells you how to find the probability for normal distribution. Then third section deals with how to find the values for the normal distribution, which is the reverse process of the second section. In the second section, by using the values, we are going to find the probability. In third section, by using the probability, we are going to find the values. So both the one or reverse process. Okay. Then fourth section tells you sampling distributions and central limit theorem. Okay, shall we start? So the first one, what is meant by normal distribution? The objective of this section is how to interpret graphs for the normal probability distribution and also how to find the areas under the standard normal curve. So I already told that normal distribution comes under continuous probability distribution. Here, what is in by continuous random variable? Just a small recap. It has an infinite number of possible values that can be represented by an interval on the number line. So we need to consider an interval. In that interval, we will have an infinite number of values. That one represents the continuous random variable. Here I have given the time spent studying can be any number between 0 and 24. So this is one of the example. The next thing, what is the continuous probability distribution? Here the probability distribution of a continuous random variable. The next one, normal distribution, which is a continuous probability distribution for a random variable x. The most important continuous probability distribution in statistics is normal distribution. Here this picture shows the graph of a normal distribution, which is called a normal curve. Okay, which looks like a bell shape. So these are all the properties of a normal distribution. Here at the center, mean, median and mode are all equal. The normal curve is a bell-shaped curve and symmetric about the mean. See, you can see in this picture. So the mean lies at the center. You can see the mean, mu value. See, this mu value lies at the center. Here the mean, median and mode are all equal here at the center. Here the normal curve looks like a bell-shaped curve and symmetric about the mean. Okay, this line is symmetric, both the sides are symmetric to each other. The next property, here the total area under the curve is 1, is equal to 1. See the picture. Here the normal curve approaches but never touches the x-axis as it extends further away from the mean. Okay, so it never, but it while if you enlarge it, you can see that the curve never touches the x-axis. But by looking, it shows that it is touching the x-axis, but if you enlarge it, it never touches. Okay, please keep it in mind. So this is the fourth property. And fifth one, you can see this is the mu value, means mu plus sigma is the in the center of the curve. Between mu minus sigma and mu plus, the graph curves downwards and the graph curves upwards to the left of mu minus sigma and to the right of mu plus sigma. So this point at which the curve changes from the upward to downward are called the inflection point. Okay, this portion, the first mu minus sigma to mu plus, this is called first standard, one standard deviation. And then the next one is mu minus 2 sigma to mu plus 2 is the 2 standard deviation. The next thing is 3 standard deviation, that interval. Okay. The next thing here, the what is mean by mean and standard deviation? I am going to explain you the difference between this by using this diagram. You can see in the first picture, the normal distribution can have any mean and any positive standard deviation. Okay, what's the difference between these three graphs? We will see one by one. The mean gives the location of the line of symmetry. Okay, and mean gives the location of line of symmetry. In the first graph, see the red color line. Red color line gives you the mean in the normal distribution, and also it tells you the line of symmetry. Okay, so this value mu, here this is mu. See the mu here in all the picture, here the mu value is 3.5, here also 3.5, but here it is 1.5. And the standard deviation, you can see here it is enlarging, the height is less. Okay, this is expanding more. Here expansion is less, here also the expansion is less. See the difference now. Here the mu value is 3.5, 3.5, but 1.5 here. See, if it is 1.5, only the curve had been shifted to the left. Okay, that's the only difference. But what about the standard deviation? Describe the spread of the data. So here for the first picture, the sigma value is 1.5. Okay, but in the second and third, the sigma value is 0.7. That's why the heights are same. You can understand what is mean and standard deviation by using this picture graph. Okay, now tell me how about you understand that mean and standard deviation we can identify by using this example. Which curve has a greater mean? Mean means which is the symmetric line. Line of symmetry tells you the mean. Okay, here the line of symmetry is 12. Here the line of symmetry is 15. Okay, this line tells you the mean. So which curve has a greater mean? Here the mean value is mu is 15, here it is 12. So the greater value in the curve A. So the curve A has the greater mean since the line of symmetry occurs at x is equal to 15. But in the curve B, the line of symmetry occurs at x is equal to 12. Okay, which curve has a greater standard deviation? Which spreads more? Okay, B only spreads more, but A not like that. So the curve B has the greater standard deviation. Curve B is more spread out than curve A. Okay, the next example, here the scale test score for New York State grade 8 mathematics tests are normally distributed. The normal curve shown below represent this distribution. Estimate the standard deviation. I already told you that line of symmetry tells you the mu value, and this value 650 tells you mu minus sigma, and 700 tells you mu plus sigma. But they are asking the next value. Okay, what's the next value here? This value represents 660. Okay, no, not 660, I'm sorry. This is 10 minus, no, 640. This tells you 640, this line, and this line tells you 710. Okay, what they are asking here, the normal curve is symmetrical about the mean, so you can estimate that the mu value here, it is 675. Okay, so this value will be, the next value will be mu plus sigma, no? This value is mu plus sigma, and this value is mu minus sigma. So here they need the value for this. So mu plus sigma is equal to 710, but here the mu value is 675 plus sigma, which is equal to 710. So sigma value is 710 minus 675. So what's the answer? It will come 5. Here it will come 0, no? So 3. So sigma value is 3. That's why you are getting this sigma is, can estimate sigma as 35. I hope that all of you can understand. So this is the solution. The next one, what is maybe standard normal distribution? When the normal distribution has the mean 0 and the standard deviation as 1, then this normal distribution is shifted as is taken as standard normal distribution. So the standard normal distribution means here the normal distribution which has the mean 0 and standard deviation as 1. The x value can be transformed into an z score. We need to always, while finding the probability, the x value should be transformed into a z score by using this formula z equal to x minus mu by sigma. So we need to substitute the x value here. We know already the mu value and sigma value. You can get it from the problem itself. After that substitution, you can get the value for z. So this z is called z score. The next thing, so in each data of x, of a normally distributed random variable x is transformed into a z score. The result will be the standard normal distribution. This picture shows. Okay, so you can transform the normal distribution to standard normal distribution by using this formula z equal to x minus mu by sigma. Use the standard normal table to find the cumulative area under the standard normal curve after this. Okay, so I will explain you one problem here. The first one, before explaining a problem, I am going to explain you the properties of standard normal distribution. The cumulative area is close to 0. Here you can see the cumulative area is close to 0 for z score, close to z equal to minus 3.49. So you can see here under this, so in this portion you can see the area is close to 0. Okay, in the here in this portion the z value is minus 3.49. Likewise here also it is close to 0, so that the z value is positive 3.49. The cumulative area increases as the z score increases, keep in mind. So here the cumulative area for z equal to 0 is, here it is 0.5. The area is 0.5. That's why here the area is 0.5, here 0.5. So totally the area is close to 1. Okay, area is 1. So in this positive direction the area is close to 1. Here it is 0, but this side the area is close to 1. That's why the z value is positive 3.49. So find the cumulative area that corresponds to a z score of 1.15. How to find from the table? For 1.15 you need to find 1.1 in the left hand column. Then move across the row. You need to move like this in this direction. Okay, under 0.05 you need to see 0.05. So the area to the left of z equal to 1.15 is 0.8749. So this is the area to the left of z equal to 1.15. Okay, find the cumulative area that corresponds to z score of minus 0.24. For the negative, here the x value is negative 0.24. There is another table which has the value of negatives. So you need to take that normal distribution table. In that you need to choose the minus 0.2 in the left hand column and move across the row to the column under 0.04. So you will get the area to the left of z equal minus 0.24 is 0.4052. The next thing, so now I am going to explain you how to find the area under the standard normal curve. To find the area to the left of z, find the area that corresponds to z in the standard normal table. To the left of z means, see, you will get the area like this from the standard normal table. Keep in mind, you can get the z value from the standard normal table, that is to the left of z. That one I had explained here. The next thing, sketch the standard normal curve. You need to sketch it and shade the appropriate area under the curve. Find the area by the following direction for each case. If it is left, to the area to the left of z, find the area that corresponds to the standard normal table. So here area to the left of 1.23, you can take a standard normal table. So how I had explained before, you need to go like that and find the area to the left of 1.23. For that, in the left side you need to choose 1.2 and move to the row, and from the column you need to choose 0.03. so at last you will have that value as 0.8907. so by using the table you are getting that area to the left of z equal 1.23 as 0.8907. The next thing, to find the area to the right of z, use the standard normal table to find the area that corresponds to z. Then subtract the area from 1. Could you understand? If you need the right side of z, so from the table you will get the area to the left of z. But the total area is 1, no? We need to subtract that 1 minus to the left of z. In the previous slide I shown you 0.8907, no? That value we need to subtract it from 1 to get the right side. Okay, this area you can get it. So I will show you here. So this value to find the area to the left of z is 0.8907. So if you subtract this value from 1, you will get the value as 0.1093. I hope that how to find the value to the area, find the area to the right of z of 1.23. We need to subtract this value from 1 to get the value as 0.1093. The next thing, to find the area between two scores, between two z scores. So for that, find the area corresponding to each z score in the standard normal table and then subtract the smaller area from the larger area. That's all. It's very simple. That is what they are saying. You need to find the left of z equal to minus 0.75 and also to the left of z equal to 1.23 and subtract the smaller area. This is the smaller area, no? Smaller area from the larger area. Okay, if you subtract these two values, you will get the area between two z scores, z equal to minus 0.75 and z equal to 1.23. So that one I will explain you now. In this example, see. So area to the left of z 1.23 is 0.8907. Area to the left of z equal minus 0.75 is 0.2266. If you subtract these two, you will get the area between the two z scores as 0.6641. I hope that you can understand how to find the left of z, the area to the left of z, area to the right of z, and also the area between the two z scores. Okay, we will do some problems related to this. First problem, find the area under the standard normal curve to the left of z equal to minus 0.99. From the table you can get the value to the left of minus 0.99. So that one they are asking. From the table itself you can get this value. Okay, this is the area. So from the table you can straight away get the value as 0.1611. The next problem, they are asking to the right of 1.06. What's the meaning of right? See, this is the area to the right of 1.06. So first of all, we need to find the area to the left of 1.06 from the table as 0.8554. Then subtract this value from 1 to get the answer as 0.1446. Okay. Here the area is equal to 0.1446. Okay. How to find the area under the standard normal curve between minus 1.5 and 1.25? First of all, you need to find the left side area. So in between I need this. First of all, we need to find the left of 1.25 from the table. Then left of area to the left of minus 1.50 from the table, and subtract this two value to get the area between this two z score. That value comes as 0.8276. Okay. Okay students, today's section is over. So what we have seen so far, I will just give a recall. So we have interpreted some graphs of normal probability distribution to show the to understand the mean and standard deviation, and I did some problems how to find the area under the standard normal curve. Hope you can understand well. So we will do some activity here. So find the probability using the standard normal distribution. P of z is less than 1.49. For that, you can straight away get the value from the table itself. So the area comes as 0.9319. The next thing they are asking for, z is greater than or equal to minus 2.31. For that, greater than means the area to the right of minus 2.31. We need to go for another table which has the negative value and find the value from the table that gives you the left. So you need to subtract it from 1 to get the area under the area to the right of this value minus 2.31. So the value comes as 0.9896. The next thing, we need the probability in between these two values minus 2.14 to 0.95. So we need to subtract the table values, that is to the left of minus 2.14 and to the left of 0.95 from the table, and subtract it to get the value of the in between value, which gives you 0.8127. Okay students, today I am going to end up this section. We will see in the next class. See you, bye bye.